So question number 6, as I mentioned at the end of the previous video, is the opposite of question number 5. It's asking you to expand each log. Expand is naturally the antonym of the word condense. It means they're opposites. So while condensing is all about taking lots of little individual pieces and shrinking it down into one single log in the answer, you're going to start number 6 with one single log, and the goal is to expand it into as many smaller pieces as possible. So here are some ways that you can do that. I'll make the disclaimer that sometimes you and I might have thought of different things, so answers could theoretically vary a little bit in letters A through F, but for the most part, I think you'll find that we'll be on the same wavelength, because the goal is just to say to yourself, how much further can I break these numbers down? For example, 6/5. 6/5 clearly is a quotient the way it's written because it has a fraction involved. So I'm telling myself pretty naturally, I must have had two natural logs. So natural log of something minus natural log of something else that would have given me a 6/5 as a result. It must have been a subtraction because I had a fraction as a result. So again, I'm just kind of thinking logically backwards. I can definitely assume that the 6 would have been first and the 5 would have been second in order, because I ended up with 6/5 as my answer. Now this is technically an expansion because you now have more logs than you started with. You started with one single log, now you have two. If you can challenge yourself to go further, it's always a good idea to challenge yourself in that way. Like, look at ln6. Natural log of 6 there could have broken down. I mean, maybe we had two separate logs that merged together as ln2 plus ln3 that together made ln6. So when you're writing your fully expanded answers, it's not like it's wrong to write ln6 minus ln5. That's totally fine. But try to make it a goal to yourself to break down every number as far as you could have. So one example of how to break this one down was ln2 plus ln3 minus ln5. Because 2 times 3 is 6, 6 divided by 5 is 6/5. Now, of course, that's not the only way you could do this. Some people may have thought they could expand it differently. I could write another example that could work. Natural log 36 minus natural log of 6 minus natural log of 5. Take a look at that answer. And notice that works too, because if I do a quotient with the 36 and the 6, there's ln6. And then if I do another quotient with the 6 and the 5, I get 6/5. So that's another answer that could have worked. I mean, you could have lots of answers that could work. You could do this all day. Natural log of 12 minus natural log of 2 minus natural log of 5. That could work, because 12 divided by 2 is 6, 6 divided by 5 is 6/5. You could have, and again, I'm kind of obnoxiously going crazy with this, just so you can see all the possibilities. Whoops. You could have had something like this. Natural log 6, natural log 1, natural log 5. 6 times 1 is 6, 6 divided by 5, 6/5. So the point of this is you can get lots of different answers and still be correct, so don't be too married to what you see on the answer key. The answer key was just the one that occurred to me, but you can do as many or as few answers as you want. Because letters A through F don't really have just one answer, I'm not going to fixate too much on those in this video. What I really want to focus on in is letters G through L, because those are a little bit more concrete. There's a little bit less flexibility with those because we don't know what these values are, and that gives us some more options. Or fewer options, I should say, which makes it easier to say, okay, yeah, we have the same answers here. So in letter G, let's analyze for a second. I see a product here. A squared is multiplying B. So I could have just as easily predicted that there were two separate logs to begin with that got added together, because again, product rule. One of them was the A squared, and the other one was the B. Now, another thing you could predict is that this square probably came from somewhere in the front. So my best guess is that the original problem was 2 log A plus log B. So it's almost like you're trying to predict what was the original problem that got condensed to give you this answer, log A squared B. Now, the way you write it could again vary. That's okay. If you wrote it as the way I wrote it up here, log A squared plus log B, that's completely correct. Totally up to you. You decide how far you want to take these. Another example, letter H, just so we can see it. predict to yourself what could have been going on here. I mean, I see a product on the top, so I could definitely predict there was an ln x plus an ln z happening, because I can definitely tell that's where x times z came from. And then I could tell myself, well, there must have been a quotient involved, there must have been a subtraction involved, because the y to the 6th ended up on the bottom of its fraction. You could have also said to yourself, wait a minute, hold on, there was a 6 there. That could have come from the front. That could have been a power that got brought up. So our best guess is that we probably started with ln x plus ln z minus 6 ln y. Again, if you didn't write that, if you just wrote what I wrote above, that's fine too. Just make sure that it multiplies and divides back to where we started. That's really the only big important thing. Last one, just again to make sure, letter J. This one had a lot going on. So let's try to predict here. I can definitely tell I had some product action on the top. I can definitely tell I had log of x to the 4th product with log of y cubed. We can see that part pretty clear because x to the 4th and y cubed multiplied. And we definitely had a product on the bottom. I can definitely see on the bottom that there was another product with log of w and log of z squared. But the problem is, and I purposely kind of wrote this separately here, the problem is w and z squared ended up on the bottom, which means whatever the product was on top had to subtract whatever the product was on the bottom. So that's kind of telling me I must have had some sort of order of operations that was telling me like, whoa, do the top first, do the bottom next, and then subtract the results. So this definitely needed a little bit more detail than it needed before. Also, you could go back and say to yourself, well, that's fine. Or you could drop the powers back down if you wanted to. So 4 log x could have been fine, plus 3 log y. But I want to show that that, in parentheses, was subtracted with a different product, log w, and 2 log z. If you don't write the parentheses, that's okay. You don't have to. You could have written this answer as 4 log x plus 3 log y minus log w minus 2 log z. But notice that's a little bit nuanced, because you would have had to realize that the subtraction, the quotient, affected both w and the z. That was why they both ended up on the bottom. So it really just depends on how you want to write it. I mean, like, this is 3 different totally acceptable answers here. Either way you write it, any way you write it, is fine. You just decide which way makes the most sense to you. These are not easy, so don't panic too much if you feel like these are definitely a big step up, and if you feel like you're not quite there yet in your mind, that's totally okay. Many of these things really won't come into play until math analysis anyway, but it's worth it to just kind of see what types of problems are out there so that you can be prepared to see why you would bother learning the product and the quotient properties in the first place. So don't panic if it feels like it doesn't make sense. Just try as many as you can. If you get them wrong, it's okay. Just do the best you can with what you've got. Ultimately, again, you're not going to need to know these until next year. They're not going to be a huge part of the final exam. They're not going to be something you'll be tested on separately. So just do the best you can with it. Try, if you can, to make some space in your head for where this would fit in the bigger picture of how to manipulate algebraic expressions, and just do the best you can. If you feel like your best isn't good enough, please don't panic. Right now, there's no such thing as good enough. We're just going to try to set ourselves as good a foundation as possible, as strong a foundation as possible, so that when we get to math analysis next year and they start talking about logs, you'll be able to say, oh yeah, that's familiar to me, and not, what? Log? Are we foresting all of a sudden? Because that's really the only thing we're trying to avoid. We're trying to avoid the possibility that next year you'd go in and say, I've never seen that before. If you have a foundation to build on, then all of that math analysis stuff will build a lot more easily because you'll have something to connect it to.